In section 7.5, we're going to be talking about solving radical equations. And these radical equations might have either square roots or they might have exponential fractions that we're going to have to try to eliminate in order to isolate the variable and solve for x. One item of note that we're going to see pop up is the idea of having extra answers called extraneous solutions. And those extraneous solutions are things that we're going to have to consider in the problems and then throw out if they do not check once we plug back in our work. So checking our work is going to be important to focus on as we work on problems today. Let's take a look at a couple examples. I picked out 9 different examples that are going to give us a good feel of the different possible scenarios that you could be approached with in a situational problem like this. All right, our first one has a fractional exponent of 2/3. And as you know, we need to get rid of this fractional exponent. It's the cubed root, and it's then squared. And so to get rid of a cubed root, we would cube both sides. And to get rid of something squared, we would take the square root of both sides. And so what we're going to do is we're going to raise each side to the reciprocal exponential power. And so what that means is we're going to take this x minus 2 raised to the 2/3, and we're going to raise it to the reciprocal power. Now, since we raised the one side to the reciprocal power, we must also raise the other side to the same reciprocal power. So we did the same thing to both sides. Now, the rules of exponents say a power to a power. In other words, the 2/3 times the 3/2, well, those two reciprocals will cancel, and that will leave us with x minus 2 on the left. On the right side, we have 9 raised to the 3/2. Let's think what that means from our work yesterday. The fraction denominator of 2 means the square root of 9. So that means the square root of 9 is 3 raised to the 3rd power. I'm just going to highlight our 2 3's because these are the same 3's carrying down from problem to problem. Here we then have x minus 2 equals 27, so x equals 29. So we can very easily check this work. We can plug in the number 29 minus 2 to the 2/3 and say, does that equal 9? Well, that's 27 to the 2/3 equaling 9. We then can think, okay, we need to take the cubed root of 27, and that's 3. And then we have 3 squared equals 9. And just trying to track where those numbers are coming from, the 2's are coming from right there. And that is correct, and so we do have an answer of x equals 27. So we can circle that answer, and we're going to move on to the next one. Our next problem is similar. We have a fractional exponent, but in this case, we have a number out front. And this 3 out front is something that we're going to have to deal with because before we can raise both sides to the 4/3, it's best if we isolate what's being raised to the 3/4. So we're going to take and we're going to start by dividing both sides by 3 and work it out that way. That's going to give us, very simply, x plus 3 to the 3/4. And then 27 is what 81 divided by 3 is. I hope you're seeing now we're going to be taking that same problem and we're going to say x plus 3 to the 3/4, but we're going to raise that to the reciprocal power because we want to cancel that 3/4, and that's going to equal 27 raised to that same reciprocal power of 4/3. The 3/4 and the 4/3 are going to once again cancel, and that's going to leave us with just x plus 3 on the left side. On the right hand side, we have the cubed root of 27. The cubed root of 27, as you know, is 3, and so we have 3 to the 4th. Perhaps you remember that raising something to the 4th power is the same thing as squaring it twice. So 3 squared is 9, 9 squared is 81, and 81 minus 3 is 78. So 78 is our proposed answer. Let's take a look and check that. 3 times parentheses 78 plus 3 raised to the 3/4 supposedly is going to equal 81. Well, let's take a look. That's 81 to the 3/4. Does that equal 81? The fourth root of 81, the fourth root of something is the square root twice. So the square root of 81 is 9. The square root of 9 is 3. So we have 3 times 3 cubed. 3 cubed is 27. And so 3 times 27 is indeed 81. So once again, that checks as well. Our third one, we have a little bit more added in to keep our problem a little bit more interesting. And so the first thing we're going to do, obviously, is subtract 6 from both sides, and then we're going to divide by 2. So we have 2 times 4 minus x raised to the 3/2 equals 16. Now we divide by 2, and we're going to get a value of 8. This is really our starting point of the problem, similar to what we had up on our first problem at the very beginning, where we just have a parentheses raised to an exponential power equals a number. And so this is really the starting point, and so let's take a look at it now. By now you hopefully are very comfortable and see that you need to take each side to the reciprocal of the exponent. In that case, this reciprocal exponent is 2/3, and so that's going to equal 8 raised to the power of 2/3. You also see that raising that power to a power, I'm assuming, is going to cancel each other out because the 2/3 and the 3/2 are reciprocals. That's going to leave us very simply with 4 minus x on the left. The cubed root of 8 is 2. 2 squared is the right, so we have 4 minus x equals 4. I'm going to bring the x over to the right side, and that gives me 4 plus x equals 4, and I hope we then see x equals 0. Perfectly fine to get a 0 answer. Let's check this and see how this pans out. 6 plus 2 times 4 minus 0 to the 3/2 supposedly is going to equal 22. Well, that's 6 plus 2 times 4 to the 3/2 equals 22. That's 6 plus 2. Notice I am not combining the 6 and the 2. The square root of 4 is 2. So we have 2 cubed there equals 22. So 6 plus 2 times 8 is 22. 6 plus 16 is 22. And sure enough, that does check. So my answer of x equals 0 is correct. So in summary on this page, we really have seen we have 3 problems that we have. We're raising each side to the fractional exponent as we try to eliminate that fractional exponent and then solve for what's remaining. This is going to be one type of problem that we're going to approach and look at in our homework tonight. Let's take a look at our second part where we're really working on a different sort of idea. But working through this, let's see how some of these pan out. This first one, we have 2x plus 3 raised to the 1/2 minus 7. So we're going to focus more on fractional exponents with 1 as a numerator here. Before you can eliminate that 1/2, you're going to probably have to get rid of the 7. I would imagine you've recognized that by now. And so we're going to take this 1/2 and we're going to bring the 7 over. How do you get rid of a fractional exponent of 1/2? Well, I hope that's pretty clear that you're going to square both sides. So when you square both sides of the equation, that fractional exponent is going to quickly knock itself out. Realize you must also square the 7. When you square something that is a fractional exponent of 1/2, that's going to knock those 2 out, leaving you x plus 3 equals 49. So 2x equals 46. So x equals 23. Let's check this very quickly. We have 2 times 23 plus 3 to the 1/2 minus 7. That's 46 plus 3 to the 1/2 minus 7. That's 49 raised to the 1/2 minus 7. The square root of 49 is 7. 7 minus 7 is 0. And that was our goal, to have a 0 value at the end. So x equals 23 looks like it's a valid answer here. And we're not going to have any extraneous solutions because our answer checked and it worked out. Let's look at example 5. A little bit different. We have a multiple thing going on here, so we're going to subtract 1. So we leave that 2 out front, and we get a 4. To get rid of the out front 2 here, just to be clear which 2 we're talking about, it's the one I've highlighted in yellow. We're going to divide both sides by 2. Nothing happens inside the square root, but we merely get that. To get rid of a cubed root, that's the exponent 1/3, a cubed root. I hope you realize we're going to cube both sides. And by now, hopefully I'm helping you see, we're going to cube both sides. That's going to knock out that 1/3 and leave us with 2 cubed on the other side. 2 cubed is 8. 8 divided by 2 is 4. And we can very quickly check this answer. 2 parentheses 2 times 4 raised to the 1/3 plus 1. 2 parentheses 8 to the 1/3 plus 1. The cubed root of 8 is 2. 2 plus 2 is 4. 4 plus 1 is 5. And that is what we are trying to get all along from our original problem of a 5 there. Okay, so in all of these, I hope this has been 5 quick, simple examples of how to solve these. And now we're going to move on to some problems that have an x on both sides of the equation. The key to these problems is going to be to try to get the square roots separated on 2 different sides of the equation, which will allow you to take each side and eliminate those fractional exponents. Now, the nice thing is if we square the left-hand side, multiply, by an exponent of 2, that's going to cancel that 1/2 out, which then means to counter that, we also have to square the right-hand side. And so we're going to square both sides of the equation here. Let me just show you what that's going to look like. Here's the first square on the left. Now we have to do that same square on the right. So we have x plus 5 raised to the 1/2, and then we're going to also square the right-hand side. So we squared both sides of the equation, and that's going to then drop those exponents out completely, leaving us 2x equals x plus 5. This is one of my favorite kinds of problems because it solves very quickly once you've squared both sides, and that allows you to see what you're going to get here. Let's plug these in and check. 2 times 5 raised to the 1/2 equals 5 plus 5 raised to the 1/2. And obviously the square root of 10 is equal to the square root of 10. All right. So we continue to have all of our problems checking, which obviously begs the question, what is this extraneous solution? We're going to keep looking for that. It's going to be a problem that does not check, even if we have an answer. Here we have our next problem. This is the first time we do not have a x value inside of a square root or inside of a fractional exponent, but we're going to follow the same procedures as before. Our first step merely is going to be to isolate the side of the equation with the fractional exponent. So to do that, we're going to bring the 3x over to the right side. Now we're going to take both sides of the equation like we did before, and we're going to raise both sides of the equation raised to the power that is the reciprocal of our fractional exponent. And once again, I'm targeting this 1/2. The reciprocal of 1/2 is 2. When we square a 1/2 power, that's going to leave us with 5x plus 4 on this side. And on this side now, we're going to get 9x squared. I need you to realize you're squaring both the 3 and the x. I'm going to set this equal to 0 and have 9x squared minus 5x minus 4. We've got to think through and say, do we know anything that this might work with? We could use the quadratic formula. We could factor this, but we do have 2 answers here. And if you very quickly, we're going to try some factors quickly. If they work, that's going to be great. If they don't, we're going to not have this working out. I just see the 9 and the 4, and I feel like those could easily combine to get rid of the 5. And so to do that, we're going to have x minus 1, 9x plus 4 equals 0. So we're going to solve those 2 equations. 9x plus 4 equals 0, and x minus 1 equals 0. On this side, that means 9x equals negative 4, and x equals negative 4/9. And our right side, we're going to have x equals 1. Here's the first time we have 2 answers that we're going to be working out. And so we're going to have to plug in both of these answers to try to see what we're going to get. On the left side, we've got that negative 4/9. We're going to plug that in, and let's do that very quickly. We've got 5x plus 4. So 5 times negative 4/9 plus 4 raised to the 1/2 minus 3 times negative 4/9. And if this works, this should be equal to 0. Well, 5 times negative 4/9 is negative 20/9 plus 4, and 4 in terms of ninths is, 4 in terms of ninths, we're going to take that. That's 36/9 to the 1/2, and then plus 3 times negative 4 is going to be plus 12/9. So over here we have 16/9 with the square root plus 12/9, and as you know, 12/9 reduces to 4/3. Well, as we work through that, that's the square root of 16/9 plus the square root of, plus 4/3, and that's 4/3 plus 4/3, and that does not equal 0 because that's 8/3, and 8/3 does not equal 0. And so here's a case where we have an extraneous solution, and this extraneous solution is going to be thrown out. So I'm just going to put a simple line through that because that's not one of our answers. If we were to come over here now and check x equals 1 in the problem, we can take that and plug that in. We'll do that here. And x equals 1. Now we're going to have 5 times 1 plus 4 raised to the 1/2 minus 3 times 1, and see if this equals 0. We've got 5 plus 4, which is 9 to the 1/2 minus 3 equals 0. Well, the square root of 9 is 3. 3 minus 3 equals 0, and so that one does check. And so in this case, we have two solutions, but only one of them works, so we only are going to keep the value x equals 1. That is where we have our first example of an extraneous solution. Let's look at example 8. Here we have a square root plus 5 equals x. I'm sure by now you're realizing that we need to isolate that square root. That's going to give us with x minus 5. I'm now going to square both sides of the equation. And when I square both sides of the equation, we're going to get rid of that square root. So that's going to leave us with x plus 7 on the left. On the right, I'm going to have x squared minus 10x plus 25. How did I get that? From x minus 5 times x minus 5, and then foiling that. Let's now set it equal to 0. X squared minus 11x minus 7 taken away from 25 is 18. I hope you quickly see that your factors for this could be x minus 9 and x plus 2. That's going to get you a 7, so that's not going to work. You could try 3 and 3 as a possibility. You could try 3 and 3 as a possibility, but I just realized that we made a small mistake, and so we're going to go back and catch that mistake, and maybe you caught it as well. When I brought that 7 over, that should have been a plus 18, and my first clue on that was the fact that the factoring did not work. And now that I see the factoring does work, it is x minus 2 and x minus 9. So my two solutions are 2 and 9. So I'm going to take those two solutions, and I need to plug both of those in to see if they work. So let's start over here on the left, x equals 2. We have the square root of 2 plus 7 plus 5 equals 2. That's the square root of 9 plus 5 equals 2. So that's 3 plus 5 equals 2, and that certainly does not work, and so that's not going to be one of our solutions. That's an extraneous answer. Let's try the 9. We have the square root of 9 plus 7 plus 5 equals 9. That's the square root of 16 plus 5 equals 9. That's 4 plus 5 equals 9. And that does work. And so x equals 9 is our solution there. Let's take a look at our last answer, our last problem here. Just like before, we're going to isolate that x minus 5 square root. and we're going to bring the 2 over to the other side. Realize this 2 is not under the radical sign. So we've just got that radical sign all by itself, and we're going to have to square both sides on this problem. Be careful when we square both sides here. The left side is pretty straightforward, giving you x minus 5. The right-hand side, you might want to write this out, x minus 2 square root, x minus 2 square root, and let's FOIL that. The square root of x times the square root of x is x minus 2 root x minus 2 root x plus 4. So just got to be careful when you FOIL that out. So let's simplify on the right. That's x minus 4 root x plus 4. It seems like the x's are going to cancel out, leaving you negative 5 equals negative 4 root x plus 4. I'm going to subtract off the 4 here, and that's going to give me a negative 9 equals negative 4 root x. Going to come up to our next column, divide both sides by negative 4. That gives me 9 over 4 equals the square root of x. So now we're going to look at our problem and say 9 over 4 equals the square root of x. To solve that, we are going to square both sides of the equation to get rid of that square root of x. And so my answer looks to be 81 over 16 equals x. And we could check that on our calculator if we wanted to, and we would find hopefully that that is a valid answer. And what I've done here is I brought up our calculator and just to show you our check. And so I have 81 over 16 minus 5, and then outside of the square root a plus 2. That equals 9/4. And then I have the square root of 81 over 16 on the right-hand side, and that also equals 9/4. So hopefully you can see that's one way that we can check our work. Obviously you have to be in math print mode to do that. So as we're looking at our problem here, we've got a very simple solution that we've got a bunch of different ways to work through this. The key idea is going to be to isolate our square roots in both cases and square both sides. Sometimes we're going to have extraneous roots, sometimes we're not, and we just need to make sure that we are checking our answers in each case as we work through these problems. So I hope this has been helpful in learning how to solve a problem with square roots in our answers. Our homework for the next couple of days is going to be this assignment down here at the bottom. We have 7 through 11 odd, 15 through 21, and then a kind of a variety of problems that we've picked out from the different selections here. So hopefully this has been helpful as we look at solving radical equations for these 3 different scenarios.